Welcome. Bill Taylor here in the Ken's 5 Digital Center. It is cloudy with a chance of learning. Hope everybody's doing fantastic. Love you too. Who's that? Hi, Cora. Good to see you. Wow, very nice. Wow, religiously. I appreciate it. Now, it's going to look a little dark, and it's mainly because I want you to be able to see the board for today's discussion. But what we're going to begin talking about first is this weather. This is a wild weather week. It was an incredible day yesterday, so our cloudy with a chance of learning was tropical Tuesday, and that was preempted because of the weather situation. Of course, weather will always take priority, and we had threatening weather from about 10:45, 11 a.m. right on through this hour yesterday, and even last night. But things are quieter now. You can see the radar's pretty clear. I've got some thunderstorms out in the Gulf of Mexico, but that's about it. Medical Center clearing, right? Dwight White. I like that. That's awesome. Hey, Matthew, what's going on, man? Good to see you, too. Yeah, it's been a while. Sean and Keith are watching. Sean and Keith are here. Glad you guys are in the classroom. There's Emily. How are you? First grader. So glad. You're going to learn a lot today. First graders that know about computer models, you're going to have a huge advantage. Okay? You're going to have a huge advantage. It's awesome. Hi, Vince. Good to see you. What's happening today? All right, so I had a big round of thunderstorms last night, and the thing is, the setup is that this is not a big cold front that pushes through and it's over. We are in an atmosphere and an environment that is conducive to some more upper level disturbances because we continue to replenish the moisture in the atmosphere. Let me show you what I'm talking about, these dew points. The dew points right now are high. They were in the mid-60s even after the rain, and look at this. We're pushing into the 70s around most of the city and area, lower to mid-70s down to the south. So the humidity is definitely in place, and even though the radar has not activated yet, here's the setup. We've got an upper-level disturbance or two that'll come in from the west. We also have that surface dry line out to the west. Sometimes that dry line acts as that surface trigger to get some thunderstorms started. So we are expecting more thunderstorms later this evening, and some of those could turn strong to severe. Now, before we even get into the discussion of it, we're going to talk about what the computer model is indicating. Now, the first model we're looking at is the HRRR, which is going to be behind me on the list of models. That's what's on the board here. And it's got a few scattered showers now. We had a little bit of light drizzle earlier, but look what happens out west. That's when the rain builds later tonight and into the overnight. Now you see this model does not show much of an impressive outbreak of showers and thunderstorms even to the west. Looks like it stays pretty quiet. And the chances, really, the 20 to 30% chance is what the probability has on it. But what does materialize out to the west could go severe, could produce hail, could produce damaging winds. So that's why we're going to have to watch this very closely. The Severe Prediction Center, let me show you what they've got for today, has us in a marginal. You can see that 1 out of 5 risk area for San Antonio, and that's going to be the whole metro. That's going to be Seguin. Well, Seguin's like right on the cusp. And definitely New Braunfels up to Austin. And then you can see Bernie, Kerrville, all in the 1 out of 5, marginal. Then you get into the yellow, that's the 2 out of 5, a slight risk. And that's going to be Bracketville, Rock Springs, almost Lakey, almost Camp Wood, Del Rio for sure, up to Sonora, San Angelo, farther north. So again, it's a possibility. You can't say 0, but it's definitely not a 3, 4, or 5. It's not a higher level risk of seeing severe thunderstorms, and they would be isolated. Has a thunderstorm ever had the white or pink color on radar? Absolutely. Great story. Question, Matthew. So the colors, remember, on a radar are determined by the return rate of that signal. So it's in decibels. So you're sending out from the radar site the signal, and then it's returning to the radar site when it hits the rain. It hits something and returns, okay? The rate at which it's returning is what's going to determine the color of what we call the reflectivity. That's all of the colors, the reflectivity, what we see on radar. So when you see the yellow, that's coming back at a pretty good rate, and then an orange or a red, right? And so what happens is, as we get into really heavy rainfall rates and hail, it'll actually turn white to even black. and that's usually going to be where the hail core is located. And you see that severe thunderstorm or that mesoscale cyclone, and inside there is where you're getting that color turning from, usually it's going to be the red or purple is the last color before you start getting into the black or white. And that's usually going to be the hail. Del Rio storms, round 4. You ready, Vanessa, right? Del Rio's been battling it out there. Good to see you. Glad you're here. Anytime. Vanessa is definitely one of the faithful viewers on my Ken's 5 Facebook family, so thanks so much. Mike Bridges in Del Rio. Good to see you, brother. Thunderstorms are still flying over Burlon. Is it Burlon? Bo? It's going to happen at 2:20, and if you want to look at the flight path, go to the Ken's 5 app or kens5.com, and we've got the flights schedule, the flight path. In fact, my girls will see it right over Helotes is where they're going to come in. They're coming into northwest San Antonio and then flying across the city and doing all kinds of cool maneuvers. It's going to be really neat, and that's going to be at 2:20. So I was going to have to compete with it before when I was looking at it yesterday, but they pushed it a little bit by about an hour because it was going to happen at 1:30, I thought, originally. And it was even planned for yesterday, but then they knew that the weather was coming, so they said, well, we better scrub till Wednesday. So it's going to be for Wednesday. So here's the thing, guys. We've got this pattern set up, and I want to show you the upper level wind model and why we have several days of rain chances. We look for the little buckles in this jet flow, okay? Like what you're looking at now, if you take a look right around El Paso into the Panhandle, see how that little buckle occurs? These are small little disturbances in this flow. So as we move this through, now look at the upper right, Thursday, 1 p.m., it looks pretty quiet. This is why chances for rain tomorrow are minimal. We might get a little bit of drizzle, but look what happens on Friday. Look at El Paso. See that big dip right there, that buckle? That's an upper level disturbance, okay? Now it's not really well defined, but look how it moves right across, see? Right there. See how it's right on top of us? Okay, and you see, and you follow that line, it's going up and down, up and down. Well, that's definitely, and look at that. See that deepening? That's a good, trough of low pressure and a lot of good positive energy right there. And there's an area of low pressure that'll form for East Texas and Louisiana. So you start tapping into the Gulf of Mexico moisture, which I just showed you dew points are around 70. So we've got plenty of moisture, good fuel in the tank. This is why we've got a lot of rain in the forecast Friday night and Saturday. Take a look at this. This is what we call the QPF. That stands for Quantitative Precipitation Forecast. And it should pop in here any second. Come on. It just did just a minute ago. And I don't know why it's being temperamental today, but sometimes it does this. But it's upwards of 3 to 4 inches of rain in the forecast for this system on Friday night and Saturday. So we're definitely looking at a good chance of rain, and it's just in time, and we would definitely need it. So since that's not coming in for us, and I just looked at it prior because it can be, like I said, temperamental, and that's why I checked it before I went on with this Facebook Live. And you'll see here, 7-day forecast is going to show you that the rain chance really escalates quickly as we get to Friday night. So 20 to 30% chance on Friday, maybe no chance on Thursday, just staying mostly cloudy. That breezy southeast wind maintains that humidity, and then maybe we pop a few isolated showers during the day Friday, but Friday night and Saturday, look at that, 70 to 80%. I mean, that means almost all of us are getting some good rain across south central Texas, and then even through Sunday, a decent chance, 30 to 40%, and that's the same Monday to Tuesday. I mean, we have several days in a row. You definitely don't want to wash the car right now because it looks like by Friday night and Saturday, it's going to definitely get wet and dirty again. So this is why, again, the rainfall totals are going to look pretty impressive over the course of the days. Craig Miller, why is it when the front hits around New Braunfels, it breaks, but as soon as it leaves New Braunfels, the front builds up again? Good question. So Craig, what is happening a little bit, even New Braunfels, but more so in San Antonio or Dallas and Houston, is an urban heat island effect. So in the town of New Braunfels, you're going to have a lot more asphalt, concrete. You've got structures that retain heat. And so what happens, it's almost like a column of warm air that inhibits storm development. It breaks down showers and thunderstorms. As those storms move into it, remember, the best environment for storms is going to be cold air on top of the warm air. And as you rise, your air is getting colder as you move away and off the surface. Well, when you have that column of warm air, when you're going from warm to warm to warm, or warm, cool, and then there's a cap of warm air on top, that's going to be that cap that prevents thunderstorm development. So it has to do with that. John, is rate the right term for radar returns? Decibels doesn't measure rate, but strength. Yeah, I guess I'm kind of mixing that up just a little bit, John, but definitely, yeah, in decibels. So that's what's kind of measuring those radar returns. I'm kind of getting out of my lane on exactly the terminology, but that's how I understand it. Shared the stream. Perfect. Thank you. Oh, you're welcome, Bo. What's up, Garrick? Good to see you, man. Hope everything's good. Do they just call those Thunderbirds airplanes the Thunderbirds just because it sounds cool? I don't know where they got their name. That's a good something to look up, Matthew. But Air Force is Thunderbirds. Navy is Blue Angels. So, yeah. Hope you're having a great day, staying safe. Mike, oh, I'm sorry to hear that, Jen. That's definitely the low pressure, you know, and dropping air pressure that can definitely influence that. So sorry to hear that, Jen. Hope you feel better. Oh, thanks, Vanessa. Staying faithful. I appreciate you. All right, so the benefits, the aquifer. So if you don't know this, we're watching the 10-day average very closely right now, because the 10-day average is what determines water restrictions in the city. And right now it's 661.7. It's going to go up because the aquifer went up almost a foot from yesterday to today. We're at the daily reading is the big number, 661. But then the 10-day average is what the Aquifer Authority and SAWS will use to determine water restrictions. If we hit 660 and they're expecting us to stay there, they will consider the forecast. Even if we hit it, they'll look at the forecast for the next several days, and if it looks as though it's going to be dry and could go below 660, or at least sustain 660 for several days, they will then, you know, issue stage 1 water restrictions. If there's rain in the forecast, like there is Friday, Saturday, like they would not go into restrictions this week, I don't think, even if we hit 660 by tomorrow or say Friday, you know, because of the anticipated rain Friday night, Saturday, they'd hold off. But either way, 660 is the number that they consider going into stage 1. Then it's 650, 650 for stage 2, and so on. So it's really close. And remember, we actually avoided stage 1 water restrictions last summer. So it's almost as though we're kind of due in a sense, because that was the first summer we avoided water restrictions in a long time. Nick, Saturday going to be a washout for Charlotte, Texas. That's down in Atascosa County. Nick, it's looking like it. Looking like a real good chance of rain for Charlotte, Texas, for sure. Bless too, Garrick. God bless you, my man. We got to hook up soon. 661.7. Yeah, that's big, right? So we're measuring a well. This is a well that's out at Fort Sam Houston. All right. So, and I think, did we do one on the aquifer? I think so. You go to the Ken's 5 YouTube for all of our Cloudy with a Chance of Learning interactive classrooms, and I think the aquifer was one of the topics. If not, we're putting it on the schedule for next week. Is it true that it's worse when the sun comes out because it warms up the atmosphere? Very good, Vanessa. Absolutely. Gonzalez, yeah, Friday night, Saturday for sure, but isolated showers, Rondo. Best chance of any storms tonight is going to be west of the city, out towards Del Rio. But we're going to have to watch those. Some of those should break up on their move east, but we got to watch either way. So Vanessa's question, excuse me, definitely a heating of the atmosphere will help further destabilize things and add to a severe weather setup. Whenever you have a warmer atmosphere, you definitely lead to a more conducive setup. All right, so Computer Models 101, that is the topic. And what I want to first tell you about what a computer model is. If you play any computer game, that's a computer program, right? Look at a model the same way, just like Minecraft or Fortnite. It's a program that responds a certain way, okay? And these are all mathematic equations, what are called algorithms, okay, that are designed to model the physics of the atmosphere. So I like to always use this as an example. When I was a kid, one of the most popular things were model airplanes. And you'd get those models and you'd make the perfect little, you know, B-52 bomber plane in your house, right? Well, that's not a real airplane, it's a model. And that's what this is. It's not the real atmosphere, it's a computer. It's modeling the atmosphere. So it's taking all of the current atmosphere data and trying to mimic the atmosphere, trying to behave just like the atmosphere would. And so you're putting in things like temperature, winds, humidity, barometric pressure. All of the current conditions are plugged in, and this mathematical equation goes to work. So essentially what it's going to do is it's going to measure how heat and moisture is moving through the atmosphere. Okay, so it's a computer program that mimics what the outside world is doing and essentially tells us what it should do as we move forward. Okay, so a couple of things about what we do is we have the current atmosphere, and it's plugged into the model program, the computer program, and then there's what's called the model output, what the model says the atmosphere is going to do, how the atmosphere is going to behave moving forward, okay? And what we do with our computer models are what are called runs, okay? Because it can change, because the atmosphere is changing all the time. Look at the atmosphere as a fluid. It's a fluid. And so a fluid, you ever hear it's a fluid situation. We don't know what's going to happen, and we're following things closely. You'll hear that terminology with news a lot. So that's why we look at several runs of the computer model, because you'll put new data in. Okay, the temperature just changed to this, the humidity just changed to that, the barometric pressure just went up or down. Well, all those variables will definitely change the output. So we will look at how those models are what we call trending. Okay, another big term when we're talking about model forecasting is how the models are trending. Like if the first run said that San Antonio is going to get a lot of rain at 3 o'clock, okay, well, then we're going to look at how that trend goes for the next run. And then we'll say, okay, a few hours later, and there's now even more rain expected at 3 o'clock. So it's trending wet, okay? It's also how we model temperatures, where we say the model might be trending colder, okay? And sometimes some of these models, and these are all the models behind me, they trend in a certain direction. Like we'll know that one model tends to be a little bit colder than another model because every weather scenario is going to be different. And so you try to look at the models objectively because every situation is new. That's one of the things I really love about the study of meteorology is that it's ever changing. You're never really looking at the same storm twice. Ever. I mean, we're looking at the same setup. That's why I love that I've been forecasting this area for 24 years. You know certain components of how this atmosphere is going to behave and how conditions will behave in this environment. For instance, what we call Balcones Escarpment, the drop from the hill country into the city of San Antonio is about 2,500 to 3,000 feet, you know, at its extremes. Well, it's a gradual, you know, it's not a sharp fall off of that many feet. But with that change, cold fronts, weak ones, love to stall out because of that drop in elevation. And so because of that, you know that, yeah, fronts will typically stall. So that's one of the nice things to know about this area. Also, the predominant wind is from the Gulf, right? But we do get a southwest influence from Mexico. That could be very dry as opposed to very moist. Well, those conditions are, again, going to change your model forecasting, or, you know, just at least knowing some of the things about your area that you can apply to each weather scenario. New Braunfels, hi Cindy, good to see you here. What's up, Frank? Ainsley, how are you? Good to see you. Hi, Ainsley. You're the man, Charlie. I can't wait. My gym opens Monday. I cannot wait to get back in the gym. It's been a while. My body's aching. You know Minecraft, Matthew. You play Minecraft? My daughter loves Minecraft. I also enjoy. I got into the Fortnite thing for a while. I never got very good at it, but it was really fun. But yeah, that's always the best way because remember, people are programming all those games, right? So that the computer behaves a certain way when you push the right button. Well, the same here. You know, people are writing out these algorithms in these computer programs. In fact, cool story. Years ago, my father sent me a story from a newspaper in New Jersey. I grew up in New Jersey. My father, before he passed away about 6 years ago now, he was living in central New Jersey near Princeton University. So he got the Princeton newspaper, right? And they wrote this story about how the geophysical lab at Princeton designed a hurricane model. They designed one and it was about to go operational. The government was going to start looking at it and using it on a regular basis. So he said, hey, I thought you might be interested in this, and he sent me the story. So I went to my boss, my news director. I'm pointing to his office over there. It was a different person than is occupying that office now. It was Nick Simonette, and I said, Nick, look, this is how models are done. This is what a model is, a computer model for forecasting, and I think this would be interesting. What if I went up to Princeton and did a story about it? He said, yes. I said, awesome. So me and Chris Day, photojournalist, flew up to New Jersey for a few days, and we met these scientists that designed this model. It was really cool. Now, funny part of that story is we do, in this business, they're called stand-ups, where a reporter is standing outside a building or standing, nearby the story. It's part of the story. They call it a stand-up, and you do it in order to show, number one, that you were there, okay, and you know what it looked like, felt like, smelled like, everything. I was there. So we're definitely going to do one. If we're in New Jersey, you got to show, like, I was physically there doing this story, right? So I do this part of the story, the stand-up, out on the campus. Beautiful. Princeton University is beautiful. Very, very historic. The buildings are gorgeous, right? And so it's great background, and I'm walking towards the camera. Here at Princeton University in central New Jersey, you're pretty far removed from a hurricane, yada, 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 right? While I'm doing that into the camera, we had my father walk by like a complete stranger, because you'll see a couple students here and there, right? Well, but the one closest to me walking behind me was my father, and he just like walked by, like, and nobody, of course, knew that it was my dad except us. It was pretty cool. Oh, yeah. All right. All right. Have a great day at work, bro. Take care, too, Garrett. God bless you. Joanne, cool info. Yeah, absolutely. Okay, so let me tell you a little bit about one or all of what you see behind me, okay? This is what they all stand for. These are the models that we look at. The RPM, the Rapid Precision Mesoscale model. The HRRR is the High Resolution Rapid Refresh. We call it the HRR. The NGM is the Nested Grid model. The NAM, the North American Mesoscale. Remember, mesoscale, so that's a description of a thunderstorm. We had a couple of those yesterday, mesoscale level of thunderstorm. The ECMF, so we also look at the European Center Medium Range Forecast. The European is said in recent years to outperform a couple of our models here in the U.S. So there's a little bit of a competition going on between these scientists. Remember, the better you write those algorithms, the better these models are going to perform over time, right? GFS, the Global Forecast System, the GFDL, Geophysical Fluid Dynamics Laboratory, that's the one from Princeton that I mentioned. The UK Met, the United Kingdom Met Office, the HWRF, the Hurricane Weather Research Model. NOGAPS is the Navy Operational Global Prediction System. SREF, the short range, did I put that one up? Yeah, short range ensemble forecast. An ensemble, we want to look at all of the models at once, kind of like when we're doing hurricane forecasts and we show you the spaghetti model. Let's look at all the forecasts at once on one map, see what they're all saying. And then I even have up there the WRF, the Weather Research and Forecasting Model. So this is one way to look at it too. I want to pull this up for you, a couple of ways that a model looks at our atmosphere, okay? This is what we call kind of the nested grid. See, that's how it takes the United States and puts it on a grid, okay? And we will have those in kilometers, like we will look at global models that look at everything at once, or we'll look at nested grids where they'll be in that box, and they could be a 20-kilometer size box, even down to a 4 kilometer. So you're really fine-tuning exactly what is that model, okay, or how much of an area that model is going to forecast. And remember, it's forecasting at every level. I mean, from surface, it's forecasting the land, it's looking at where clouds will be, it's mimicking ocean, it's mimicking land, it's mimicking every part of our planet and our atmosphere. And so it's very fine-tuned as far as exactly what is being modeled within that program. And then look at it as a column, you know, that vertical exchange, you know, because it's measuring things from top to bottom, from bottom to top. I mean, all those grids are considered when this model is doing its forecasting. So it's really important to understand that, again, it kind of grids it out and looks at all different things, okay? What does GPS stand for? Well, that's the Global Positioning System. That's going to be this, or Global Positioning Satellite, I think is what the GPS, your GPS stands for. Because remember, it's using a satellite in space to determine where you're located on the planet. Big thank you, always keeping us informed. And we love Del Rio, absolutely. Vanessa, we love you guys. And remember, you guys are in a 2 out of 5 risk area later tonight. So we're going to be watching close for you guys, okay? Nothing in the short term. And you can not worry about that, because I know the storms could affect you guys later tonight. I see lots of Weather Channel people do stand-ups. They must check. Yeah, absolutely. They're always at, especially Jim Cantore. The joke is, if you see Jim Cantore show up, uh-oh, you better get out of Dodge, because it's going to get bad wherever he shows up. Some rules. I wrote down some notes here to share with you. Some rules that we have about the models. Never ever consider one model's forecast. No matter how well you trust it or it's performed in the past, it could be performing poorly with the given scenario. Every model is going to do everything differently every time. So it's really important that you consider all of them. You watch the model trend. I mentioned this. If you see that it's wet at 3 o'clock, see what it's doing in the next run and seeing if it's now trending drier at 3 o'clock or wetter at 3 o'clock. Pay attention to what those models are doing in the short term and each run in the long term. Model accuracy, just like any forecasting, decreases as you move away. So if you got 24 hours, you're in really good high accuracy rates, 48. Now you're going out 72. Now so as you go out in time, your accuracy is going to come down exponentially, because again, you've got, a little farther removed from the scenario. Because remember, models perform better and those runs improve every time you're plugging new data in, and that data you're plugging in is current. So you can't plug in, tomorrow's data till tomorrow. When you do plug it in, now that rerun is showing, okay, now Saturday's looking a little drier, or it's looking like the rain doesn't hit until later in the afternoon, okay? Keep an eye on the ensemble forecast, the consensus. We like to see, are all the models agreeing in different ways? So let me show you now the practical use, like all of this, right? I don't look at all of these models. I look at most of that first column as far as what we look at on a daily basis for our weather, okay? And what I'm going to show you now is the model forecast. I share this all the time. This is a visualization. Like in the last, when I started in this business 30 years ago, there was no visualization of the models. You had to look at all these numbers, okay? And there was really no other way to share it with you except to say on television, well, it looks like the models are saying this. Kind of like what they're saying, you don't see the model data with the coronavirus, but you'll hear government officials talk about our models are suggesting, well, they're using computer model forecasting for diagnosing the coronavirus, or the amount of cases we expect, the amount of deaths we expect. That's all forecasted with computer models with the coronavirus. Climate change, all of these different things, they're using models for the forecasting. And so it's something that you're becoming more and more familiar with all the time, but it's used in more than just meteorology. Model forecasting is used in, again, pandemics, and it's very important. Okay, but it's the same principle. Remember, instead of modeling the atmosphere, the computer model for the virus is modeling, diagnosis and cases and things like that. So here's the first thing we do. We pull up our computer model, and we want to see how well, I've talked about this before, how well the computer model is doing with the current situation. So the rain, this is not a live radar picture, this is a computer's interpretation of a live radar image, okay? So it's 1:35 right now, right? And we don't have any rain in the area. The radar is completely clear. So this model, as I mentioned earlier, is the HRRR, okay? And you saw that on the list, the HRRR. Now, I've got what I'm looking at on my computer desktop is a drop-down menu with all of the different models that I'm going to look at and consider, okay? So let's go to the ECMWF. Do you remember what that stood for? Come on, come on. No, we just called it the European. So this European model, whoa, it should be raining this much right now. The European is thinking, okay, so now this to trust it moving forward is kind of a bad idea because look at how much it's missing in the current situation, right? It's not even raining outside. It's cloudy, it's muggy, but it's not raining. So we'll go to the second European because that's a global European model. The North American model is about the same, okay? So I'm going down the drop menu, back to the HRRR, just as we pass it by. It's a little bit better, okay, as far as how it's interpreting the current situation. Now, this is called the GEM. This is a model that's available to us here. It's a 10-kilometer high-resolution model, and that's pretty good. It's just got a little bit of rain from Seguin close to New Braunfels, all right? So we keep that in mind. So far, that's the best one, though, right? Now the GFS, and it's also got a lot more rain than is reality. Here is another rapid refresh, and that's also missing it a little bit. So far, we're still looking at this GEM 10-kilometer as the best performer thus far. As we now go to the IBM model. Now, this is the model that was designed by the company that puts out this software and this user interface. Okay, so that's also just kind of missing it a little bit. Here's the NAM, okay, we have that on our list, and the NAM is predicting that we've got most of the rain off to the east, a little closer to reality because we have some rain out in the Gulf of Mexico, so the NAM's not doing too bad. That's 20 kilometer. Here's the NAM at 3 kilometers, and it's got a much more wet situation, especially down to the south and east. Now the RPM, and that's also got a lot more rain than is reality. Okay, I like that one. The 12 kilometer is doing a good job. How's the 4 kilometer? A little more. So I like this RPM, okay? It's really difficult to get a handle when you don't have any rain out there at all. It's better when you have, okay, we got some rain near Seguin, we got some rain near Kerrville, and you can find the computer, it's, oh wow, this one's matching really well, it's doing good. So this one's doing the best so far, okay? So we'll use this model, and now we'll see how it's operating moving forward. So as I just showed you, we always consider more than one opinion, right? You want to go to a doctor for a second opinion. Same thing here. You go to another model or two for more opinions, and you see how they're all performing at different times. Now see, this model brings in the rain for Del Rio at about 7:30 this evening, and then pushing east and holding together a pretty good thunderstorm over Brackettville before 9 p.m. and then really popping, look at that, between Lakey and Uvalde at 9:30 tonight, and holding together, getting even stronger as it hits into Hondo at 10:30 tonight. So this would bear some watching because, again, a 1 to 2 out of 5 chance that what you're looking at is producing hail and damaging winds tonight. So these are storms we're going to have to watch closely. So make sure you've got the KENS 5 app. Make sure your phone's charged. We will be on Facebook Live right here if this happens tonight, okay? Now, as the storms get into San Antonio, notice they break up for the city but hold together to the south. This is 1:30 in the morning after midnight, heavy rain. We were talking to Charlotte, Texas a minute ago, from Pleasanton down through George West and Tilden. Okay, and that's again 1:30 in the morning and holding together to push down towards Victoria, Port Lavaca by 4:30, 5 a.m. and then clearing. Okay, so it's going to be one impulse and then how far east it gets. Okay, so here's one thing to do. 10:30. There's a good time frame where it really kind of blossoms up right over Hondo, right? So what I'll do sometimes when we see this, let's see if there's a consensus with the models, right? So we're back into our what we call the builder on here and there. We'll stop that at 10:30 and now go through the models at that hour and see what they're saying. So the European at 10:30 has moderate rain over San Antonio up to Fredericksburg with no big thunderstorms. There's the North American European, okay? So this is where I'm looking for a consensus. Are the models agreeing with each other? And they're really not. You can see that the Europeans did not have the same match with the RPM was the first one, and neither does the HER. Look at that. The HER has nothing going on. All right. The GEM's got a little bit of rain at the Rio Grande, but nothing like what we saw with the RPM. But remember, the RPM was performing best right now. So that's why we trust it the most. The GFS has pretty much the closest to that scenario with the big storm, heavy rain in a line, but just a little bit behind it, okay? But we call that pretty close. We call that a consensus, an agreement, all right? Here's our other rapid refresh, says no. The IBM says, oh, this says pretty good, pretty close, with storms right over top of us. But you can say, again, just like the GFS was a little behind, this one's a little ahead, but they're both pretty much saying the same thing with a good line. So this is a pretty good consensus. Now the NAM, boy, it says nothing at that hour. The 3-kilometer NAM says it's still west at that hour. So at least 3 models are agreeing with our RPM, which one was it? The 12. Yeah, there we go. Model, which again was performing best. So we've got a pretty good consensus. That's 3 models out of the 6 or 7 that I looked at, showing that we've got a good chance of getting some of that rain in here by tonight and later tonight. Yeah, Sandra, 2:30, Thunderbirds. I got to show you this picture, guys, from yesterday. This came in from Jesse and Tanis. Now they live in the Mountain Springs subdivision of Canyon Lake. Now, I'll pull this up close. Oh, not me. This one. So you can see, look on the right side. Now, this is an electronic station. They've got a really nice setup out there, and Jesse and Tanis' son, Marcus, sent me this. You can see temperature, you can see humidity, you can see the feels like, and this was at 5:30 yesterday afternoon. Look at the rainfall total, 8.52 inches. That is unbelievable. That's a 24-hour period. 8.52. Wow. And remember, even though it's a 24-hour reading, it didn't happen over the course of 24 hours. That rain over Canyon Lake yesterday and Comal County, it was about 2 to 3 hours. That's why it led to flooding on the Guadalupe River. And the river is like at its banks right now, just about bank full. An amazing amount of rain yesterday. Just amazing. I had a map that'll show you. Let's go to the 48-hour. And look at these. So those are the pockets right there of big-time rain. All right. Cuero even got some. Let me show you some of these totals. I'll pop in the number there. Cuero, that little red, 6.5. And then look, right off I-35 for 7.5. Here's Canyon Lake, right at 7.5 as well. I mean, just amazing. And this is a rainfall estimate. So it's a little lower than the actual gauge that family sent me from Mountain Springs on Canyon Lake. And that's something? Just an amazing amount of rain and a lot more in the forecast. As I showed you, 7-day, and that's where I'll leave this before we go, is giving us a good indication that we're going to have a lot more rain come Friday night and Saturday. The chances right now are running 70 to 80%. And then we hold on to rain chances through this time next week. But the highest will be Friday and Saturday. So again, please make sure you're staying tuned. We could see some flooding issues on Friday night and Saturday with that kind of rainfall in the forecast. But first and foremost comes tonight. Remember that tonight we do have the risk of seeing some severe weather out to the west. San Antonio in a 1 out of 5 chance. Del Rio a 2 out of 5. So make sure you're keeping your ears on. We will update you here on Facebook in the event of anything that's occurring, of course, on Ken's 5 television, and we'll have everything. What are Thunderbirds? So, Sandra, the Air Force Thunderbirds are going to be flying over the city at 2:20. They're coming in near Helotes, and if you want to see the entire flight plan and see if they're going to be where you are, or you want to get to where they're going to be overhead, you can do that too at kens5.com or the KENS5 app. We've got the flight path of the Thunderbirds, and it should be really cool. You'll see them in formation flying over as a tribute to our healthcare workers today, because God bless our nurses and doctors for the work they're doing. A lot of extra hours, and then they've got families too, and a lot of them are quarantining. I got a buddy of mine that's a doctor. He's living in his basement, until this is all over, because he's going to the hospital every day. So it's a dangerous situation. He's got 5 kids, so he wants to make sure that they don't have any exposure or any chance. All right, that's going to wrap things up from here on our Wednesday edition of Cloudy with a Chance of Learning. Tomorrow, Paul Morales talks about heat's effect on the body. This is a very important topic for South Texas. We get hot in South Texas. You can see that we're hot and humid, 93 by next Wednesday. And it won't be long before we're talking triple digits. Well, that puts a lot of stress on your body. How does that work? What are the signals to look for? So make sure to stay tuned tomorrow for the KENS5 Facebook and YouTube broadcast of our Cloudy with a Chance of Learning. That's going to wrap things up for me from here in the KENS5 Digital Center. I love you. You know I mean it. Take care. God bless y'all. And we'll see you on First at 4.